Today, we'll talk about the earliest members of our genus, Homo. The earliest hominins who walked bipedally that have so far been recovered date to between 6 to 7 million years ago. Their brains were still ape-sized. Initially, these early hominins were arboreal, with the capability of walking bipedally. They show a mosaic of ape-like and hominin-like characteristics. So how do we know that they were bipedal? Well, we can tell by the location of the foramen magnum and the cranium, and by other postcranial parts to the body, such as the curve to the lower spine, the shape of the pelvis, the angle of the femur, and the knee and foot anatomy. The earliest bipedal hominins that have been recovered from between 7 to 6 million years ago. We've already talked about the first 5 of these genera, Sahelanthropus or Roran, about whom we know very little, and then Ardipithecus, Australopithecus, and Paranthropus, about which we have many more fossil remains. And the topic of today is the earliest Homo. We believe that some of the gracile australopithecines may have been in our lineage, but we know that the robust australopithecines, which I'm calling Paranthropus, were not in our lineage, and they went extinct. Homo, our genus, first appears 2.4 million years ago in East Africa. Now, what led us to put this early hominin into our genus? Well, 2 related items. First, we find a substantially larger brain, anywhere from 20 to 50% larger. And the first use of stone tools, or so we thought. However, we now have stone tools that predate Homo in Africa. The major problem that we face is that we often find stone tools without finding any associated skeletons, or we find skeletons without any associated stone tools. So when you find stone tools by themselves, it may be difficult to figure out what hominin or human made them. So far, the oldest stone tools date to 3.3 million years ago in East Africa, whereas the oldest Homo dates to 2.4 million years ago in East Africa. I'll group Homo into several various groups that we'll talk about. Early Homo would include Homo habilis and Homo rudolfensis, which had been found only in East and South Africa. Middle Homo includes Homo ergaster, also found in Africa, and Homo erectus, the first long thought to be the first hominin to spread outside of Africa. And archaic Homo, many different species. And finally, modern Homo, Homo sapiens, which is the only Homo to look like us. We have several problem or unusual Homo, including Homo naledi and Homo floresiensis, which I'll talk about later. Today's topic will be to talk about the early Homo and the middle Homo. How many species of early Homo there were is in contention, as well as how different they were from australopithecines. In other words, should we consider these species to be Homo, or should we still continue to place them into australopithecines? We'll look at the following early species: Homo habilis, dating from 2.4 to 1.4 million years ago in East and Southern Africa, and Homo rudolfensis, 1.9 million years ago in East Africa, dating from the end of the Pliocene into the Pleistocene. So what sets Homo apart from Australopithecus? Well, the major difference is the first significant increase in brain size, anywhere from 20 to 50% larger. Not only is the brain bigger relative to body size, but it's been reorganized. We see more development in the left cerebral area, like our brain. This is the area of the brain that impacts right-handedness, language, and the ability to use symbols. Some early Homo are so much larger, many paleoanthropologists are willing to consider them a separate species called Homo rudolfensis, from East Africa. So whereas Homo habilis was about 4.5 feet tall, Homo rudolfensis was 5 feet tall. I am going to consider them all to be Homo habilis. But just in case you run across the name, here's a little bit about Homo rudolfensis. So far, only one skull has been recovered, and elsewhere several thigh bones may be Homo rudolfensis. This creature had a large brain, a less pronounced brow ridge, and less prognathism, and a long face and large molars. So what species to assign to particular fossils among the early hominids or early Homo is not agreed upon. And these problems should clear up as we find more early Homo fossils. But presently, early Homo is found only in eastern and southern Africa, and most of these fossils are very fragmentary and scattered. The Homo habilis cranial characteristics include that the back teeth are still large compared to us, but smaller than earlier hominins. So this marks the beginning of a general trend in humans towards smaller teeth. Now, as you might imagine, smaller teeth also might be related to prognathism. So as your face becomes less prognathic and more flat, like our face is, your teeth also then would need to become smaller. Compared to Australopithecus, it has a larger cranial capacity, and this is the beginning of a trend. Less postorbital constriction, that is, behind the eye constriction, and a more rounded cranium with no sagittal crest. Along with this, the zygomatic arch, or the cheekbones, are smaller, and there's a less massive jaw. So the sagittal crest, zygomatic arch size, and the jaw size all go together. Because if you recall, the sagittal crest was an anchor to the large jaw muscles, and the zygomatic arch had to be larger to allow those temporal muscles to pass underneath them. So this is kind of a package. As you have smaller jaw, then you have smaller jaw muscles and no sagittal crest. They also have a smaller, slightly less prognathic face compared to Australopithecines. And related to that, they finally have a parabolic dental arch, like we do, whereas Australopithecus had a U-shaped arch, or dental arcade. Looking at postcranial characteristics, basically, Homo habilis bodies look the same as Australopithecines, except that the hands and feet are more modern. So like Australopithecus africanus, they were still climbing trees as well as walking, and they had long arms and short legs. Their rate of maturation appears to have been faster than us today, more like modern-day ape maturation rates. And they still have a lot of sexual dimorphism, more than we see among humans today. We see high variability in body size, and we're thinking perhaps it's differences between males and females. Now, not everyone agrees that we should even have a species called Homo habilis. Several scenarios are in contention. The old version was that Australopithecus led to Homo habilis, which led to Homo erectus, which led eventually to us. The recent version leaves Homo habilis out as either a non-existent species or an extinct species. I've inserted here a Far Side cartoon by Gary Larson. Given what you've learned so far in this class, why is this cartoon extra funny? Well, let's look first. He has written genus and species correctly, capitalizing genus, not capitalizing species, although he has misspelled the species name. But the picture itself, what do you notice? The fossilized footprint of a brachiosaurus and a Homo habilis thrown in to boot. Well, hopefully you remember that dinosaurs went extinct at 65 million years ago, and Homo habilis doesn't show up till tens of millions of years later. So no brachiosaurus could ever have squished flat a Homo habilis. However, on the plus side, he's holding a tool. Early Homo populations were around for 1 million years or less, and all early Homo populations have been found only in Africa. Before they disappeared, a new species called Homo erectus branched off. We have long thought that Homo erectus was the first human to migrate out of Africa, but now we're not so sure, and more on that when we talk about stone tools. So at the end of the Pliocene, between 3 to 1.8 million years ago, we find several types of hominins. Several species of Australopithecus, the gracile type, several species of robust australopithecines called Paranthropus, and Homo habilis. So in other words, Homo habilis potentially could have met 4 other species of hominins. Let's move on to talking about the Middle Homo, who lived during the Pleistocene, otherwise known as the Ice Age. During the Pleistocene epoch, from 1.8 million years ago to 10,000 years ago, we know of perhaps 15 cold periods when glaciers covered higher elevations in northern areas. In between these glaciated periods, we have interglacials, which were warmer. During glaciation, unglaciated parts of the world had cooler summers and wetter winters. During glaciation, the sea level dropped because much of the world's oceans were caught up into glaciers. So the water level dropped as much as 410 feet. So for example, Florida was much wider than it is today, as were many coastlines. Now, one implication of this is that if you had an early human site of people living on what was then the coast, today to find that site, you would have to go out on a boat and do underwater archaeology. It's difficult to track the glaciations on land because glaciers, as they progress or retreat, wipe out evidence of earlier glaciations. However, based on oxygen isotopes in sea sediments, we can divide the Pleistocene into 3 sections: the Lower Pleistocene, the Middle Pleistocene, and the Upper Pleistocene. Different humans lived during each subdivision of the Pleistocene, but by the end, modern humans had appeared. So the earliest Homo sapiens like us appeared during the Ice Age. So approaching or into the Lower Pleistocene, we find late Paranthropus, early Homo, and Middle Homo. So let's talk now about Middle Homo. Homo ergaster has been found between 1.8 to 1.3 million years ago in eastern and southern Africa. We are going to include it as part of Homo erectus rather than a separate species. Homo erectus is found in the Lower to the Upper Pleistocene, that is, throughout much of the Pleistocene, and it's been found not only in Africa, but also in southern Europe and west to East Asia, including the islands at Java. It was long thought to be the first human to migrate out of Africa, and not only that, but to do so during the Ice Age. It is the first human with an average cranial capacity within the modern range of variation. However, its skull did not look modern, and now we may have earlier hominins outside of Africa. Let's take a look at the cranial characteristics. On the left, at the top, you can see 2 Australopithecus skulls from the side. In the middle, 2 Homo habilis, and at the bottom, 2 Homo erectus. The brain case is low and narrow. It has a sagittal keel, which I'll show you in a minute, and postorbital constriction. We can see the postorbital constriction here on the lower right, where the skull kind of squeezes in behind the eyes. The brow ridge is prominent, that is, up above the eyes, and the occipital torus is also prominent, and that's a bump at the back of the head. The cranial capacity ranges from 600 to 1,250 milliliters or cubic centimeters. The bones of Homo erectus are thick, including the cranial bones. The teeth are smaller than were australopithecines, but the lower jaw remains rugged. And as you can see, it does not yet have a chin like we do. So the Homo erectus skull is widest at the base, and when you look at it from the rear, it looks rather angular. And that top angle is on the sagittal suture, hence we call it a sagittal keel. Compare this to a modern skull, which has no keel and is widest at or above the midline, not at the base. So if you see the back of a Homo erectus skull, it's very characteristic. The only thing that looks a little bit similar is Homo naledi. John Gershay has reconstructed faces of Homo erectus. Now, the postcranial body is essentially modern, but muscular. Hence, if you look closely at these comparative skeletons of Homo sapiens, Homo erectus, and Australopithecus afarensis, you can see that, first of all, the pelvis is narrower than ours, and that the bones are thicker, signaling that the muscles are very strong. And I want you to also note the change in rib cage shape from Australopithecus, whose ribs flare out at the bottom, to Homo erectus and Homo sapiens, whose ribs kind of constrict in a barrel shape at the bottom. So if you recall, John Gershay's earlier reconstructions of Australopithecines and their big bellies, that is linked to the shape of the rib cage. So postcranially, the body of Homo erectus is larger than Homo habilis, but we don't have many Homo erectus postcranial remains. But the body looked fairly modern, except that it was short, stocky, and very powerfully built. But the arms, the legs, the pelvis, the vertebra, hands, and feet are similar to modern. The differences that really stand out are how thick and flattened the femurs are, indicating how muscular their legs were, and the hips are narrower. And compared to Australopithecus, the rib cage now looks different. It's now barrel-shaped like ours, not conical like Australopithecus. There is evidence that sexual dimorphism is greater than now, but less than it was for Homo habilis. Turkana boy, who was about 8 to 9 years old, died about 1.6 million years ago. At the time, he was already over 5 feet tall and weighed about 106 pounds. We believe that his cranial capacity would have reached 909 cubic centimeters or milliliters in adulthood. But because 40% of the skeleton has been recovered, we have a pretty good idea of what he looked like. So again, note the change in the shape of the rib cage between Australopithecines and Homo habilis versus Homo erectus. So Australopithecines had a flaring out rib cage at the base, and Homo erectus is the first to have a barrel-shaped rib cage like ours. So the belly would no longer be huge like it was in Australopithecus afarensis. And we'll talk about the significance of this in relation to brain size. So Homo erectus had a longer maturation than before, more like us, but still faster than us. Now, of course, our pelvis size is limited by bipedalism. And for a newborn to be able to pass through the mother's birth canal, the baby's head must be small compared to its adult brain size. So Homo erectus babies were born more immature and more dependent on adults than had been babies of early Homo or Australopithecines. Among modern Homo sapiens, a 9-year-old brain size is only 95% size of the expected adult size. So a long maturation period after birth provides time for learning. This chart shows the different brain sizes that had been measured for some of these early hominins, early Homo, and Middle Homo. So from left to right, it's small brain size, to the right, larger brain size. And you can see that Homo erectus has many different brain sizes, but it's the first to average within the modern brain size. And these brain sizes overall look substantially larger than Homo habilis, and Homo habilis brain sizes look substantially larger than australopithecine or gracile australopithecine brain sizes. So overall, Homo erectus was around for about 1 million years, and it was a period of species equilibrium. There are some trends, but they're very gradual. Molars do tend to decrease in size over time. The lower jaw size decreases. The incisors relatively increase in size as the molars are getting smaller. And there's a slight increase in cranial capacity through time. But the rest of the Homo erectus skeleton remains very stable. So Homo erectus are the first humans whose average cranial capacity falls within the range of modern variation, but their skulls do not look modern. Homo erectus is long thought to have been the first humans to radiate out of Africa into Asia and Europe by 1.8 million years ago. But now we have stone tools in China at 2.1 million years ago, and stone tools in the Republic of Georgia at 1.8 million years ago. Neither of these sets of tools are associated with skeletal remains. And we'll also talk soon about the implications of moving out of warm Africa into colder regions during an ice age. Let's quickly review what I've said about early Homo during the Pleistocene. So Homo habilis lived during the Pliocene into the Pleistocene only in Africa, and neither the body nor the cranium look modern. Homo habilis does have the first larger brain than australopithecines and definitely made stone tools. But not everyone agrees that this is a species or is in our lineage. And for our purposes, we'll include Homo rudolfensis within Homo habilis and talk only about Homo habilis. The Middle Homo during the Pleistocene includes Homo erectus, living from 1.9 million years ago to 110,000 years ago. Homo erectus has been found not only in Africa, but in southern Europe, in Western Asia, Eastern Asia, and including the islands of Java. Some separate out the African specimens as Homo ergaster, but we will not. We'll consider all of these to be Homo erectus. The body is fairly modern, but muscular and stocky. However, the cranium is not like ours. It's low, it's long, it's keeled, even though the average cranial capacity falls within the range of modern sizes. When you look at the timeline of hominin evolution, with the oldest at the top and today at the bottom, you can see that Homo rudolfensis and Homo habilis, which I'm grouping together as all Homo habilis, were living at the same time as a number of other species. And Homo ergaster and Homo erectus, which I'm grouping together as Homo erectus, also lived at the same time as other species.